In this problem, we have a car sitting on ice. Coefficient of static friction is pretty low. The car has a mass of 1,300 kilograms plus a little bit. And the question is, what is the largest acceleration it can achieve without having the tires slip? So we want to state our answers in G's at the end, and converting from acceleration in meters per second squared to G's is just a matter of dividing by 9.81 meters per second squared. So what do we know? Well, this is the static friction problem. And static friction is always less than or equal to the coefficient of static friction times the normal force, which in this case is mg. Well, we're asked, what's the maximum acceleration? Well, what's acceleration? Acceleration is force, acceleration comes from Newton's second law, F equals ma, right? So acceleration is just force over m. What's the force in this case? The force in this case is static friction. So what's the largest static friction can be? The largest static friction can be is this mu s mg divided by m. All right, so mu s mg divided by m. Well, the mass cancels out. Mu s g. That's the largest acceleration we can achieve. Let's go over here and calculate it. We've got mu s 0.065. We've got g 9.81. Right? And so in meters per second squared, the largest acceleration we get to is going to be mu s times g. All right? Not a lot of acceleration. You're going to have to take it easy if you don't want to start your tires spinning. And here's the problem. Remember, kinetic friction is always less than static friction. So once your tire starts spinning and you're in the kinetic friction, you actually have less power than before your tires were slipping. You have the most ability to accelerate just before your tires slip. So if you're ever on ice and your tires start slipping, you want to get that to stop. You don't want them slipping. Okay, now, final bit. We're going to convert this acceleration to g's by just dividing by g, which leaves us just with a over g is mu s. Right? So the answer to this problem, after you do some work, you're going to get down to is just what you were given in the beginning, 0.065. G's is the acceleration that you have available to you on ice, on this ice. And that's it for this problem.